Come to our next two speakers from NBCUniversal, and they have done an implementation to change their journalist's life using the cloud. So I'd like to get up on stage Kevin Fornito. Kevin is currently the manager of production infrastructure at NBCUniversal, and he's responsible for the provisioning and automation of core infrastructure, the porting, the broadcast production. And the second speaker is Zembower. He's currently a system architect at NBCUniversal, focusing on hybrid cloud, automation, and orchestration for the production engineering group, which is supporting the live studio operations at 30 Rock. So I hand over to you both. Thank you.
The clicker thing? Oh, there we go. Cool. Thanks, Yvonne. With the need to lower the overall cost of doing business while generating more content to stay competitive with other media outlets, whether broadcast, digital, or social media, we at NBC set out to evaluate a fully cloud-native media creation platform, one that is nimble, automated, and elastically scalable. Media creation is an integral component of broadcast television production. On any given day at NBC, thousands of graphic elements are created for news broadcasts, late-night entertainment, websites, digital streaming platforms, and even mobile applications. Over the past year, we've been evaluating a cloud infrastructure model to provide on-air media creation as a service back to our internal creative teams. But before we dive into that, let's discuss what traditional broadcast media creation infrastructure looks like today. Tight deadlines and the demands of live television production require creative teams to be equipped with high-performance graphic workstations, high-bandwidth networking, high-performance shared storage. Traditionally, these requirements force creative teams to be centrally located with physical hardware and cabling. A typical NBC creative artist workstation consists of the following: a Mac or PC tower workstation, dual desktop computer monitors, video router control panels, broadcast video monitors, tons of network cabling, both 1 and 10 gig connections, and peripherals like Wacom tablets. In addition, there are numerous back-end servers that support media creation workflows, including directory services, font management servers, plugin license servers, databases, and file shares. All these applications run on physical hardware in the data center, and they're accessed from desktop workstations and applications over the network. As these services directly impact data-driven graphics for on-air broadcasts, they're run on enterprise-grade redundant hardware with high-bandwidth network connections. And then we have storage. High-performance storage is a necessity in any media creation environment. Artists need fast, reliable storage that can handle large media files. The storage must be built with robust networking, not only to handle the large media files, but also to allow for collaboration. Artists and editors need a file share that allows them to work on the same content simultaneously. These files ultimately get delivered to production control rooms for on-air graphics playback. Both SAN and NAS solutions highlighted on the screen take up a large physical footprint in the data center, and they're expensive to commission and maintain. High performance, low latency, and data reliability comes at a premium price. As you can see, the traditional media creation environment is largely physical, highly complex, and capital intensive. This model just isn't scalable, and it's not sustainable in 2019. We need a more agile infrastructure, one that could scale and provide these services on demand. Chris.
Kevin and I dressed the same today accidentally, so I had to wear a hat so that you guys would know I'm Chris. So, I think he stole my slide, but that's okay. Oh, so Kevin has painted a really good picture here of what these edit and graphics systems look like today at NBC. We have a whole bunch of equipment both at the edit bay and in the data center, and this is how we've always done it. You know, what's the problem? You know, well, there are some clear limitations to this approach, and we have some bullet points up there, but I think they all point to more or less the same fundamental inefficiency, which is a total lack of flexibility. Let's say that we're starting up a new digital marketing department or a post-production outfit within NBC. On day one, we have no idea what that eventual headcount of that team is going to be. So what do we do? Do we go out and buy a whole bunch, pre-provision a bunch of hardware, go into the data center, add some storage? No, what actually honestly happens is, I'm sure some of you have seen this, is you spin up a new production and they get a whole bunch of like garbage hand-me-down equipment and like no real resources to get to do great work and produce content with high production value. Also, do we have capital allocated in advance? Do we have the manpower to install these things? What if we need to quickly scale this group up? What if that this production is highly successful? We need to quickly scale up to take advantage of that, to capitalize on that, or maybe it's something with a seasonal demand. What if that team grows, or relocation becomes necessary? Maybe we have a satellite location or remote workers. These are realities in a large organization that we deal with every day, and we're constantly trying to come up with ways to deal with this in a nimble fashion. And the worst aspect of all, in my opinion, is what we call, Kevin and I coined the locked island problem, which is the underutilization of resources. And you have these monstrous machines, both at the desk and in the data center, that sit idle, maybe worst case scenario 80% of the time, but usually at least overnight. And we've deployed some tools out there, like to take advantage of idle CPU cycles to do rendering and things like that, but you still have just a ton of wasted resources. And these things are consuming valuable real estate, power, cooling, all at the same time. So in the data center, we've solved some of these problems by adopting server virtualization. Old news, I know. But by doing this, we're taking a big first step towards resource and operational efficiency by abstracting some of that underlying plumbing that's required to run all the back office and sort of generic technology infrastructure. So this is great. We no longer have to call up the IT department or the server build group with a budget code and request a new system and then wait 2 weeks while it's racked and stacked and provisioned. I mean, that right there, that's a huge win. We can sort of self-serve to some degree. Instead, we build a large cluster of hypervisors and then carve it up as we need to. And of course, this is great. But so far, we're only talking about back-end systems, and we're not addressing any of the real problems that we were talking about with the production experience, with our creative user base. And so by doing server virtualization, we've definitely jazzed up the data center, but we're straight heavy metal at the desks. So how do we take advantage of some of this virtualization out at the desk? And well, that would be VDI, or virtual desktop infrastructure, which I'm sure many of you have heard of or used. So by running an agent on the machine, the virtualized machine, we can deliver that desktop experience out to the desk. That user could be sitting at a laptop with a software client or some sort of thin client or even a firmware-only zero client. So now we're getting somewhere, right? We can start slimming down the footprint at the desk, and we can start even thinking about remote artists. So this is amazing, and everybody wants to move in this direction. Let's just do it right now. Why didn't we do this 10 years ago? Well, you've all probably used various remote desktop protocols over the years. VNC, is kind of like the one everyone knows. And they've been around for decades, and I think we can all agree that they are not suitable and are extremely limited. At least these first-generation VDI tools are very limited in their ability to deliver a desktop experience, let alone one that is rich media-based, that is media-centric, that's sensitive to quality, latency, or, God forbid, synchronized audio and video. So I don't know, Kevin, at this point, I just feel like maybe we should just give up. I don't know if we can do it, man.
Yeah, you're right, Chris. VDI was a big advancement in technology, but it was originally designed for task workers, right? It's users who do word processing or email, not for artists and editors. Artists and editors, they require true color representation, large resolutions, high frame rates. Original VDI was optimized for Windows desktop, not for moving video and animations. But the good news is, over the past few years, enhancements have been made to virtual desktop delivery protocols, and they can provide now a more faster interactive experience. And artists who connect to VMs over these protocols share the same experience as those who connect directly to their high-powered physical machines. But the biggest hurdle to bringing VDI to the media creation industry is the need for GPU. Within the last 5 years, a specialized virtual GPU solution was introduced that integrates with a hypervisor to allow a physical graphics card to be carved up and divided and allocated to virtual machines. The hypervisor now treats the GPU the same way it treats the CPU, RAM, and storage. And this breakthrough in technology allows graphic-intensive applications to utilize the graphics card as it would in a physical hardware workstation. With these improvements, VDI is now a viable option for media creation workloads. The model provides the same benefits as traditional server virtualization, so centralized resources, ease of management, increased security, but there's still limitations. Although it's more easily scalable than individual workstations, this solution's still not elastic. Physical servers must still be purchased to handle the worst case utilization. And these servers, although we're buying fewer in quantity, they're expensive and they're bound by hardware limitations. So even though the workstations have been virtualized and consolidated, artists and editors still need high performance storage. We still need to wire up a SAN or a NAS just to these virtual hosts. So the next phase in this journey is to virtualize the storage. Storage virtualization, as you can guess, allows us to take physical storage from multiple devices and pool them into a single virtual storage capacity that can be accessed by the clients. Recently, the introduction of hyperconverged infrastructure has simplified this process. Cool. So now we virtualize the backend servers, we virtualize the GPU workstations, and we virtualize the storage. But we haven't re-architected anything. This is an example of what we call the lift and shift model. Physical systems have been replaced by their virtualized counterparts, but now instead of managing hundreds of physical workstations, we just manage hundreds of VMs. The technology has advanced, but the ease of management is not. We need an automated approach to simplify management and maintenance. What do you think, Chris?
Great handoff.
Yeah, that was bad.
I'm the automation guy. Well, so I guess since we last talked, I feel like we came a long way with Kevin's help, right? We got multiple layers of virtualization, and we have some cutting-edge protocols that can deliver high-quality audio and video to our end users. But like Kevin said, from an operational perspective, we've basically just shifted from managing physical resources to managing virtual ones. And of course, that in itself does offer a lot of process efficiency value that we've discussed here. But I feel like we haven't changed a whole lot about the operational component. So what if, just thinking outside the box, what if broadcast systems architects and post-production engineers adopted best practices from the software industry? Maybe from DevOps and site reliability engineering tool sets, all the cool stuff. And what if we treated our infrastructure as living, breathing software applications? Suddenly, our maintenance requests start to look more like software release notes with highly specific and repeatable procedures known in advance. And our lab environments start to look more like GitHub forks. So our strategy for rolling out a new system or updating an existing configuration radically changes, to the point that we fundamentally alter how we think about reliability, security, documentation, and disaster recovery. We've already taken advantage of automation in so many other ways in broadcast and distribution. This is really just the next logical step, in my opinion, and not really a giant leap. It's just a new paradigm. So, and honestly, not just for media creation workstations, that we're talking about here, but for production and control room operations as well. So I think Kevin and I'll maybe come back next year and talk about what we're working on there. By utilizing infrastructure as code and its close cousin configuration management, the same amount of effort goes into managing 1 or 1,000 systems, provided they're identical and all that. But these tools are literally what make web scale possible. So in order to fully realize this promise of the tooling and the philosophies that we've discussed here, there's one more pesky little problem. We're still managing all of our own equipment. We're still going out and buying a whole bunch of stuff and racking it up in the data center. We're still running a ton of fiber. We're still paying for real estate. maybe for a whole bunch of equipment in a co-location facility or in a really expensive data center in the middle of, I don't know, Midtown Manhattan. And cooling and power and all that to support these systems. So I think you know where I'm going from here because it was in the name of the presentation. The public cloud the providers of the public cloud services offer the next leap in our journey of abstraction. They enable us to offload so much of our day-to-day engineering operations, which are really shifting what that means. Day-to-day engineering operations have really shifted, I think, over the last 5 years. Not only that, they're inviting us to automate, and they're dangling the promise of a codified infrastructure in front of us and constantly rolling out features at a clip that we could never match in the private data center. With the cloud, we can scale quickly, really quickly, and if we take advantage of automation, we can scale in ludicrous mode. With cloud, we consume resources on demand, and this means that we could deploy or goodnight an entire operation with an API call. We can spin up or shut down everything associated with the project. We could send all of its assets off to archive. 6 months later, we could revive those assets and rebuild the infrastructure and rehydrate the whole operation. When I say we could, we do. We are doing that. This brings enormous benefit to seasonal production, right? Sporting events and live shows, election cycles, holiday specials, which otherwise we're spending a lot of capital way far in advance to plan these things out. And our friend from Harmonic alluded to this sort of problem. But we see rooms full of equipment sometimes that are kind of like, oh, that was election cycle last year. Do you guys have any need for this equipment? And we do our best to reuse that, but it's a problem. But beyond that, we also can realize countless benefits to everyday production environments. So, some big enablers of media and entertainment migrating to the public cloud that have only been available for the past year or two include, we've talked about some of this already, GPU accelerated compute, Flash and even now NVMe-based storage, scalable storage clusters built around those storage technologies, policy-driven data tiering between different storage layers and providers. There are newer protocols targeting broadcast and post markets, providing network-centric audio and video delivery at increasingly high quality, despite their compressed nature. And opportunities for direct network access to cloud providers via cross-connects at co-location facilities enable us to have high bandwidth links just about anywhere. And as we discussed earlier, high-performance VDI solutions that provide multi-display 4K at increasingly high frame rates. And beyond that, of course, all the good stuff that just comes with moving to the cloud, which really boils down to outsourcing our reliability SLAs. So this is our old slide? Oh, this isn't our latest presentation, but I'm going to talk to that slide anyway. So all of this leads somewhere. About a year ago, we formed a specialized team and set out to build a truly cloud-native solution from ingest to delivery. And the project was treated as greenfield with no constraints, no dependencies to legacy infrastructure or workflows. We tried our best to forget what we knew and build something totally different. And we're happy to report by utilizing the tooling and practices we've discussed today, we're now providing full end-to-end media production workflows for creative teams in the public cloud. So how does this actually work? Well, we built a custom API that triggers an automation stack to provision workgroup environments at scale, deploying and configuring all of the resources necessary for a team to collaborate and get straight to creating. Workstations are provisioned from scratch using the latest OS images. Once booted, configuration management tools install the necessary graphics and edit software, drivers, et cetera, et cetera. Newly created workstations are automatically added to our directory services, registered with our backend systems, check in with a VDI connection broker, and then make themselves available after they've been provisioned for use. Storage clusters are spun up on demand and associated with those workstations. Ingest pipelines are provisioned to get media into the cloud via accelerated transfer. And by design, all provisioned workstations are non-persistent, meaning we destroy them when we're done with them. We could destroy them literally every evening and spin them up the next morning. This allows our administrators to manage one master OS image as opposed to many individual images. And you can imagine there's like some really interesting security implications there where you can, if you tear down your entire user-based infrastructure, let's say at the end of the week, you're not really worried as much about ongoing patch management and vulnerabilities, things like that. In our environment, all of our user data lives on shared storage, and that persists despite the fact that we may tear down their instance. When a user logs in the next day, they may not even know that they're logging into a new system. Okay, you're up, Kevin.
So you can see some of the solution benefits on the screen. Scalability and the ability to provision systems on demand allows us to give power back to our show leads. No longer do they need to call up the engineering department to design, order, wire, and configure systems. Through a web front end or an IoT button, we can provide a creative team with the ability to build their own infrastructure to match the exact needs that they need, their exact needs at any given time. A showrunner could decide he needs 20 new systems at 6 a.m., and by 7, when the first artist comes in, logs in with their credentials, they can access a newly created system that's pre-configured with all their applications and necessary files. So let's just discuss some of the lessons learned from the past year. A big one is, as we discussed before, an OpEx versus CapEx model, right? Public cloud offerings follow a pay-as-you-go operating expense model. There's extensive financial planning that needs to be done before deciding to migrate workflows to the cloud, and a total cost of ownership calculation needs to be made before deciding what to migrate. For us, working in 30 Rock and Midtown Manhattan, it's not just the physical servers themselves, but we have to take into account rent, power, and cooling. And as you can imagine, rent in 30 Rock is pretty freaking expensive. The public cloud pay-as-you-go model is only cost-effective if the systems are properly managed. Configuration management tools can provide a powerful solution to this problem by using smart policies to hibernate resources when idle. And with seemingly unlimited resources in the cloud, teams may be tempted to over-provision systems as they did in the physical hardware model. This is unnecessary, and it leads to excessive costs. It's important to right-size systems as they're provisioned. A successful migration to the cloud should be seamless to the end user. If implemented the right way, there should be no difference when the artist or editor sits down at their station or any impact to their day-to-day operations. Maintenance team, on the other hand, they'll need to adjust. Instead of maintaining physical hardware and wiring, these teams now have to focus their maintenance to the underlying systems. Most of the application layer remains the same, but the management of the virtual infrastructure and the automation tools, like Chris discussed, will require a change in both the skill set and the structure of maintenance teams. And security is a big one. Security is always a concern when it comes to migrating workflows to the public cloud. Now your proprietary company information is hosted in data centers hundreds of miles away, so additional security measures need to be put in place, including encryption, secrets management, identity and access management. We'll also discuss some of the technology gaps that we've seen implementing this in the past year. As we discussed, VDI protocols have been rapidly improving over the past couple of years and made it really possible for us to do this. But desktop resolutions are still growing, right? Now people, instead of dual HD monitors, they have dual 4K monitors. So the protocols are keeping up with it, but you need to make careful network considerations as well to keep up with the increased bandwidth, especially if multiple displays are needed. Compatibility with touchscreens and other peripherals has been a challenge, but it's constantly improving. IP audio and video is another technology gap. Recently we've had new technologies for audio and compressed video over IP. This provides the opportunity for us to migrate more workflows, but also provides a whole new array of architectural challenges. We've had some issues with software and licensing. In the traditional hardware model, we would just buy physical servers and load it up as a license server for plugins and fonts. In the public cloud, we could virtualize this stuff, but it's more of that lift and shift model we discussed. So we're constantly challenging third-party vendors to provide cloud-native SaaS solutions for licensing. And then one of the biggest challenges we'd like to call out is file delivery to and from the cloud. Source materials needs to be ingested so that creative teams can manipulate them, and then final assets need to be delivered back to on-prem to be played out in production control rooms. Network bandwidth and security considerations must be made, and media-specific file delivery options need to be addressed. And while it's true that most of the underlying technologies we discussed today have been around for a while, it's really only in the past year that all the pieces have kind of come together and enabled us to host fully automated end-to-end media creation platforms in the public cloud. We've tried to pioneer this effort, and we're going to continue to migrate as many workflows as we can going forward. With that, I guess we'll open it up to questions. Thanks.
Hi, thank you for the presentation. My name is Mauricio from Ericsson. You touched a little bit on points about requirements, but what are the minimum requirements for a creative user for the device, and what's the network requirements that you need in order to achieve a great production experience?
Sure. Yeah, I think it depends on the workflow. We have kind of different classes of creative workers. We have ones who just cut out headshots in Photoshop and stuff like that, and then we have desktop editors. So typically, you know, they're pretty beefy systems requiring anywhere like 4 gigs of GPU memory, 64 gigs of RAM, a serious amount of cores of CPU. But what's cool about the public cloud is we can kind of right-size systems. Like back in the day when we had physical architecture, you know, if we had 70 artists, we'd buy 70 of the highest power systems and put them across the board in case people needed it. But here, we could have different classes of workers. The lower class gets a lower tier, cheaper model, and the higher tier editor gets a higher tier model, and we can go on that. And then if we need to update specs, we could do that on demand. Today, Joe needs a higher powered system. We could, through one line of code, spin up a higher powered machine. So it gives us a lot of flexibility in the cloud model.
With regards with connectivity, bandwidth, and latency?
Yeah, so I think for the delivery protocols itself, we don't have to worry, as we did in the physical model, where we had to worry about workstations connecting to high-powered storage and having that fast pipe. Because both the workstations and the storage are all in the cloud, we don't have to worry about that. What we do have to worry about, though, is the latency of the actual image delivery, right? Like their representation of the desktop. And for most of the protocols we've seen, you need probably 50 to 100 meg for a true dual HT experience. Yeah, in less than 30 milliseconds latency.
Okay, thank you.
Yeah.
Those were basically the questions I was going to ask.
Great.
Since the title, my name is Al Kovalek. The title of your talk, you called it Infrastructure as Code.
Yep.
A lot of people are familiar with everything as a service, which has been around for years.
Sure.
How are you differentiating everything as a service from infrastructure as code?
Cool. You want to jump in, or you want me to take it?
I mean, that's kind of a new concept, infrastructure as code.
Yeah, we like to
Everything as a
think that what
service.
we built was a platform as a service, and it was made possible by utilizing infrastructure as code. So
Why don't you call it everything as a service? I'm trying to figure out the differential here.
I don't even actually know the term everything as a service. I know that there are lots of
Google
things
it.
as a service. But yeah, I think we like to think of what we've built is a platform as a service. Infrastructure as code is more a methodology. It's not in the same class as something like something as a something, even though it sounds the same. Infrastructure as code is a design principle. It's a mentality. It's an approach to software or to infrastructure development that was kind of took off over the last maybe 5 years with the adoption of public cloud and API-driven workflows.
One other question about really high-end uncompressed workflows. People are doing, when they're doing high-end editing, everything's uncompressed. Are you actually using the cloud to expect to get that kind of performance off of storage when it's not defined through QoS?
Yeah, so we're definitely able to do 4K source material in the cloud to an edit bay in real time, and it's fine.
Glitch-free.
Yeah, it's glitch-free. The challenge, as Kevin pointed out, and we have to wrap up here, but the challenge, as Kevin pointed out, is delivering it to the end user, that representation of it, which is going to be compressed. I think just to what you're getting at and what a lot of people in the room are probably thinking, and to just nip that in the bud, technology has this kind of vector that you can't really stop. It's only going to get better, right? So 5 years ago, none of this was possible. Imagine what's going to be possible in 5 more years. We're going to have we're getting 4K now. What are we going to be able to do 5 years from now? That quality of that compressed delivery is something that we aren't going around saying, no, we can't do this. We can't do this. It's not good enough. We're saying, let's start it now. And we're actually not trying to appeal to the user base that has those sort of like super high bar requirements of quality. We're kind of appealing to like new productions and new users who are only used to cutting on a laptop and delivering to Snapchat and to Facebook, because honestly, we like to think that our competitors are like, I mean, from our technology perspective, our competitors are more like Facebook and Google and YouTube than they are like, say, the other three-letter acronym broadcasters. So just as far as like gross aggregate viewership and, you know, content production. So yeah, with that being said, I think, yes, you bring up a really good point, and we totally agree. Like, quality is a concern. We think that we are going in the right direction and that the quality is just going to be there.
Thank you.
You're welcome.
And one last, just very quick question and answer, please.
Hopefully this will be quick. Jonathan Solomon with IBM Aspera. How do you guys handle, since I'm guessing this goes against your budget, how do you handle billing back to your customers?
Yeah. Yeah, it's a challenge that we're dealing with now. We've been working pretty hard over the past year to come up with like a cost per user type model that we can kind of advertise and sell internally to our clients. So we take into account both the storage, compute, file delivery, VDI protocols, all that. We kind of aggregate those costs. We eat them in like one master payer account and then allocate back out to the shows at the end. But we try to break it down to a cost per user to make it easier for our teams to digest, because it's a new world for them. They're used to just making capital purchases and being done with it. So,
Thank you.
Yep. Thanks.
Wonderful.
Cool. Thank you very much.
Thank you both, and give them a round of applause.